Good morning, Algebra 2. It's Mr. Mazzola here, coming at you with a brand new video. This is going to be for your AMI attendance. There'll be two questions posed throughout this video, so make sure you watch it. They're going to be, so I know where to get your attendance, make sure you watch the video, and there'll be a Google form that you need to fill out. Make sure you sign the Google form as well when you answer the questions. There'll be two questions posed through the video. On the Google form, I'll say question 1, question 2. I'll let you know which question is which. That way you can't just skip through it. So you got to watch all of this gory math here to get the two questions on there. If not, you're not going to get your attendance. And if someone does it and then they tell their friends, I'll be really sad. So you got to make sure they suffer through it too, because this is a good video. It's for review. You have your test tomorrow still. We voted on it. So don't be all like, oh, I hate math. I know. Same. But oh well. Let's get through this video though. So first things first, composition of functions. So that's the thing that I wanted to spend more time on, that sadly we just didn't have time in this last week to do so. So we're going to do a little bit of review. I came up with some amazing functions here, all color coded and everything. We have f of x is equal to x minus 9, g of x is 6 minus 2x, and h of x is x squared minus 3x minus 28. So these are just random ones I came up with on the spot. So let's hope they work out nice and well. So let's see f composed with g of x. Now, by definition of the composition of functions, this is telling you f of g of x. Now, this is literally telling you, replace your g of x with whatever it's equal to 6 minus 2x. So I'm going to try to color code this as much as I can, right? So f of, and then 6 minus 2x now. If they're equal, you can replace them at any given point, whenever it's convenient. So that is what g of x is equal. So now, this line right here tells you every time there's an x in f of x, we are instead replacing it with a 2 minus 6x. It's very subtle. So now you're taking that f function, which is x minus 9, and replacing that x, or wherever there was an x, in that function with a 6 minus 2x now. So 6 minus 2x minus 9. And usually, just to be safe, put the 6 minus 2x in parentheses. In this case, it doesn't matter too much, but it's a good habit to get in, minus 9. And now we just combine like terms. There's only one x term, so negative 2x, so that's j chilling. And then you still have the 6 minus 9, which is negative 3. So your final answer for f of g of x is negative 2x minus 3. So that is our answer. Now, on the other note, what if we had g of f of x? F of g of x and g of f of x are not equal. I'm just going to rip that band-aid off now. And if they are, that means they're inverses of each other. We'll get to that later in the semester, which is pretty dope, because inverse functions are very handy, especially when you're doing encryption and decryption of codes from different stuff. That's where it's mainly used. Let's do g of f of x. So this time around, this by definition is g of f of x. Now remember, on this line right here, we just replace your f of x, or in this case g of x, with whatever is equal to. And with equality, the special thing there is you can replace it at any given point. They're interchangeable. So now, this is going to be g of, and f of x is x minus 9. So let's replace it with that. And now this line right here, as you remember from our transformations of functions unit, this is telling you every time in your g function there's an x, we are replacing it with an x minus 9 now. So g is 6 minus 2x, so this will be giving me 6 minus 2. Oh, there's an x. So replace that x that's typically there with an x minus 9. And then just simplify. So it'll be 6 minus, and then you distribute. So minus 2x. So don't forget to distribute the negative as well. So negative 2x. And plus, because that's a minus 9, negative 2 times negative 9 is positive 18. And now you just simplify. So negative 2x is just alone again. And then 6 plus 18 gives you 24. And that's our answer. Now, we are going to do the h function now. I know, it's going to be obnoxious. However, before we do that, I'm going to answer or ask you question 1. Question 1 being, what would g of f of 2 be? So g of f of 2. That's going to be question 1. So you're going to answer that on the Google Classroom. So g of f of 2. Now, I'm not just going to throw that at you and be like, oh, no, good luck. No, I'm actually going to do f of g of 2. So I'll do f of g of 2. You're going to do question 1, which is g of f of 2. And then I'll give you question 2 later on in this video. First, let me do f of g of 2, just to show you how to do that. So now, f of g of 2 is, well, first, that's f of g of 2. So first, we got to find out what g of 2 is. Oh, this is a terrible example, actually. Hang on. Let me replay, because that's a very confusing. All right, g of f of 1. You're going to see why f of g of 2 would have been a terrible example, but let's do f of g of 1. So you're still doing g of f of 2, though, so don't forget about that. So f of g of 1. So that means we got to find what g of 1 is first. So g of 1 is going to be, well, let's plug in 1 for g. So g of 1 is 6 minus 2 times 1. So that's going to be 4. So our answer for g of 1 is 4. So now you use that answer that we literally just got and plug it in. Because remember, g of 1 is equal to 4, so that means we can interchange them at any given point. So now that's going to be f of g of 1 is just f of 4. Because g of 1 gets replaced with a 4, because they're equal. So now you just plug in 4 for f, which is 4 minus 9. So your final answer is -5. Very similar trick there. And the reason I changed it from a 2 is because you plug in 2 for g, that's 6 minus 4, which is 2. And that would have been the most confusing example ever. But now, remember, question 1, g of f of 2. Put that in the Google form. And now, I'm going to do one obnoxious example. And then I'll give you question 2, and then we'll call it. So, yes. Let me erase this. And then we're going to do the obnoxious example. Or I'm going to do the obnoxious example, and you're going to suffer through it. So here we go. We are now doing h of f of x. So h of f of x. It's better than h of g of x. So now, doing this, we are now doing h of f of x. So that means h of f of x. So f of x is x minus 9. So h of x minus 9. And that's telling you every time in your h function, there is an x replacing it with an x squared minus 3x minus 20. Yes, we're replacing it with an x minus 9 instead. So this is telling you x squared minus 3x minus 28. Instead of x squared, it'll be x minus 9 squared minus 3x minus 9 minus 28. So it's just substitution. Remember all the way back with the systems of equations? Yeah, this is substitution. So now, this is not x squared minus 81. If you put that, I'll be a sad math teacher. No, this is FOIL. Remember, x minus 9 squared is telling you x minus 9 times x minus 9. It's the first, outer, inner, last, right? So this turns out to be, and there's a trick to it once you do enough of these, x squared minus 18x minus 8 or plus 81 distributed to 3, or negative 3, negative 3x plus 27 minus 28, and then just combine some like terms. So that'll be x squared, and then negative 18x minus 3x, that's minus 21x. 81 plus 27 minus 28. Oh, that's just 81 minus 1. So it's plus 80. Boom. Not too bad at all, actually. Wow, that was underwhelming. Yeah, well. Anyway, your question 2 for today is, what is your favorite animal? And why is it your favorite animal? Respond to that, and that'll be question 2. Good luck. Let me know if you have any questions. I know you got your test tomorrow. It's a big one because it's important since it's a good one. Make sure you prep. Make sure you don't slack, and email me with any questions. So see ya tomorrow.